Hi guys, so we'll continue our journey with pandas and we'll learn how to clean data using pandas. We'll be working on the same Netflix data frame that we had worked upon earlier. Let me just show it to you. So, if you remember, this is our Netflix data that we are working on. Okay, it's got like some 7,000 rows. These are the columns: title, rating, rating level, rating description, release year, user rating score, user rating size. Okay, now as you can see, there are a lot of blank values in this data. Okay, we don't know that whether there is duplicate data or not in this. Okay, then uh, duplicate titles are there or no in this. So all these things we need to see. So we need to clean up our data. Okay, some scores have got NA in them, not applicable. User rating size. So how do we clean this data? That is the question. So for that, we can use pandas. Okay. Now, the first thing that we'll do is drop duplicates. Removing duplicate values. So, okay. But before that, in this program, we need to first do the basics. Import pandas as PD. Import numpy as NP. Then data frame is equal to pd dot read underscore csv, and then the name of the Excel file Netflix shows dot csv, and we are good. df dot info. Okay, let's check if everything is working fine. Yes, it is. We've got our data in the data frame. So far so good. Okay, now what we have to do is we have to drop duplicates. Removing so if I were to do df dot drop underscore duplicates, okay, now what happens, how this works is that if you want to create a new data frame, okay, so you do df1 is equal to df dot drop duplicates, okay, and then you print that information of df1 dot head and df1 dot info. Okay, let's see how this works. So initially there were 1000 rows and there were 7 columns. Okay, and then there are 500 rows and 7 columns. Okay, so 500 out of these 1000 rows have disappeared. Now how did that happen? If you see duplicates, a lot of these rating levels are the same. So whichever rating levels are the same, they have removed all the repetitive values except for the first one. So now how this drop duplicate works is you have to give a argument called keep. So if you do keep is equal to first, okay, this is the default value. So when the Excel is checking for duplicate values, it will come here parent strongly cautioned and parent strongly cautioned. So it will keep this first value Gray's anatomy, and after this all these parents strongly cautioned wala values which are there, they all are deleted. It will just keep the first occurrence. Similarly, you can say keep last. So it will only keep the last occurrence of any repeated value. Okay, or you can keep this as false. If you keep this as false, okay, then it will remove all the values, not even the first one will be kept. Okay, so now if you see df1, you will see 256 rows in this. All of them will have everything that is unique, nothing is repeated. Okay, So this checks for repetition in each and every column, not just this one. Okay. Now I don't want to remove duplicate values of ratings. I want to remove duplicate values occurring in the title column. Okay. So for this, I need to, and I want to keep the first value. Okay, I don't want to remove all. So keep first is anyways the default. So even if I don't give the keep argument is okay, but I still need to give another argument out here, which will tell that I have to use the first column. So I want to drop duplicates from this titles wala column. Okay, title. So what I'll do is I will do df dot drop duplicates subset is equal to title. So what we'll do is if the title column has any title which is repeated, it's gonna get dropped. Okay, otherwise it won't be dropped. So here you can see that out of 999 columns, now only 496 columns are remaining in the data frame. That means that all the titles that were there, they are double. Okay, they were double, and I think most of them have been removed in this drop duplicate. Now what remains are the only unique titles in that 1000 wala. Now let's move on to cleaning up data, streamlining the columns. Okay, so firstly, print out the column names. You can do this by print bracket, sorry, where is print bracket df dot columns. If you do this and if I run it, it gives me a list of all the columns that are there in the data frame. Okay, now if I want to change all the columns in the data frame, okay, I can do it this way. df dot columns is equal to, and I can give my own list. So let's do that. Title, comma, rating, comma, rating level, comma, rating description, comma, release year. Now if you were to see the original name, it is release space year. I'm making it release year, and I'm changing all the column names slightly. Like here rating level had a capital L, I removed that. Capital D, I removed that. I just made a very simple column name that I can use. Now user rating score, I'll do user rating score, or I could have done user underscore rating underscore score, whatever is easier. And the other one is user rating size. There. So these are the columns that I have defined. Okay, and obviously I have made a syntax error somewhere. Yeah, I have not put quotes here. Now we are good. So df dot columns is this. Now if I do this, it changes all the columns of the database. So now if I do print df1 dot head, sorry, just a minute. After this, if I were to print the df1 dot head, and if I were to print the database columns, data frame columns, okay, df dot head, not df1 dot head, it would be this. Okay, now you can see that the now the column names have changed out here, and the column names have changed out here also. Okay, you can see that. But you can also see that we are back to 1000 entries out here. Okay, this drop duplicates wala entire event, it happened in df1. It did not happen in our original data frame. We want it to happen in the original data frame. For that, what you have to do is you have to remove df1. You have to just do df dot drop duplicates. But this will not work unless you do an argument called in place is equal to true. So if you do in place is equal to true, it will actually change the original data place and it will not work on a copy of the database. So now when I run this program, instead of 1000 rows, it will give me back that 476 or 496 rows. Okay, and the columns which are named as per my wish. Okay. Now, if I did not want to change all the columns of a data frame, I want to change only one column name. I'm okay with the other names. Okay, how do I do that? I will, if you remember, the data frame is built from a dictionary where the key is a column name. Okay, so you have to do, you have to use the rename method. Okay, and you have to use do it via dictionary. So how that happens is df dot rename. Okay, now what we do is columns is equal to, and now how you change a key name, that way you have to change the name. So the old column name is user rating size. Okay, now I'm using this as the old column name. Okay, and colon, and here I will put a new column name, that is just size. Okay, so now let me print df dot head and df dot columns. It's gonna have changed only this one column. So this method, okay, the method of writing a list is useful when there are few columns in your data frame and when you want to change all of them. If you want to change only one or two of the names, you can do this method, the dot rename method. Okay, so there you go. Nothing has changed. I think I know why, because we have to again put in place is equal to true, because all of these things methods, they work only if you do in place equal to true. Otherwise they'll work on copy on the of the data frame. The reason is data protection, of course. Now when you see size, okay, so here now we learned how to work with columns. Now let us learn dealing with rows with null values. Okay, we have to deal with rows having null values. That is our next task, right? So first is get rid of rows or columns with null values. That is one option that you can do. Okay, so if any row has a blank value, just delete the row. So here there's a NaNa and here there's a blank value. So if you do blank value, it's gonna really delete the row. But in our case, you don't want that. Why? Because if it deletes the row, then this Marvel's Iron Fist ka other details also won't be present in our database. Okay, so we don't want that. So we'll use option 2. We will replace the null value with not null values using imputation. Okay, that is the second option. So option 1 is delete all rows with null values. Option 2, replace nulls with not nulls using imputation. That's what we are going to do right now. Okay, so first, identifying the null values. For this, we have to use is null statement. So if you do print df dot is null. Okay, this will print all the rows which are null. So true, false, false, false. So whatever is true has a null value in it. All the true things have a null value in it. Okay, in our data frame. That is one thing. But again, since the visibility here is very limited, this is of no use to us. We want a summary of column wise summary of null values. How many null values are there in each column? Right? So what you have to do instead is print df dot is null, okay, dot sum. Okay. So this will give us a column wise summary of null values. So in title there are no null values, in rating there are no null values, in rating level there are 32 null values, rating description none, release year none, and user rating score mein there are 242 null values. Okay, so user rating 4 is a problematic thing for us, because if we were to, now let's see what happens. Okay, let's try option 1, that is delete all rows having null values. Okay, we'll try option 1. We'll not do it on this data frame, we'll do it on a new data frame called df2. df2 is equal to df dot drop na. So if I were to do drop na, okay, and save it in a new data frame, it will drop all the null values that are there, all the rows having null values. So let's see what we are left with. So we'll print df2 dot head, okay, and print df2. There you go. Now we are left from earlier 496 rows. Now we are just left with 244 rows and the 7 columns. Why? Because all the null value wala rows are removed. Okay, but we don't want that, as I discussed, right? We want the second option, that is replace the null values with not null values using imputation. Okay, now from this we realize that user rating score has the maximum null values. Okay, we have to replace the user rating score wala column with some sensible rating. So you see this user rating score NA, it has the maximum number of null values. So we have to replace this NA with a meaningful number, okay, and so that it is streamlining the data. So how do we do that? Okay, so let's work on this user rating score column. Okay, now let's make a panda series, which is, I have just focusing on the user rating score column, and this column I'm putting it in a panda series called score. Okay, so first let's see the details of this score. Score has 244 rows and 7 columns in it. No, that is the df2, sorry. A user rating score looks like this. Okay, there is nothing much. Top 5 rows have been printed, nothing else, no details have been printed. Now what we'll do is we will print the mean score. Okay, the score mean is 81. Okay, so now if I replace all the blank values with the mean, okay, it will not change the mean of my entire data. If I were to replace all the blank values with some other number, it will change the mean of the entire data, okay, and it will give me a wrong value. But if I were to replace all blank values with this 81.318, that is the mean, okay, then my data ka mean will not be changed. Okay, so I will do that. So in imputation, the idea is to replace the null value with any sensible value. Here I'm using mean for demonstration. You can use any other value if it makes sense in your data set. So now what I have to do is I have to do score dot fill NA. Okay, that is, here I'm dropping the NA. NA is blank value. Here I'm filling the NA. Okay, with the mean. Okay, so let me give this score mean is equal to score dot mean to this. So fill NA with score mean. There we go. Score dot fill NA with score mean. Okay, now when I again do again I have to do in place is equal to true. If I do this, okay, and now if I check my this data frame dot is null sum, I will expect those values to have gone. There you go. There is no 0 in user rating score. My data is good. Okay, and imputing the mean does not change the mean of the data set. Now let's say you want to look at how your Excel sheet, this Netflix shows.csv, looks now. So for that we must export data frame to new Excel. So let's do that. So how we export data is we do df dot to underscore csv. Up here, if you remember, we did pd dot read csv and csv file name. Now we are going to do data frame dot to csv and csv file name Netflix shows 2. There we go. Okay, and once it's done, I'll just print that file exported and we are done. Okay, so there you go, file exported. Now I want to see the new file, which is, it should be somewhere here. Netflix shows 2, yes. So this new file, okay, as compared to the first file, has a few changes in it. Now what are those changes? See, this is the first file. The first change that is there is the columns are different. Okay, and this file has 1000, whereas here the column names are as per what we defined, and this file has 497 values in it. If you go to see, there you go, right? All values are unique, and in the user rating columns, all the ratings which were blank have now got the mean in them. Okay, so whatever you have done is working. That is what you can see out here. Okay, apart from this, there are a lot of other changes that you can do in this. Now we have worked on this data set in the lock and iLock Pandas section. So we've already done a few changes there, or we found out the data or movies with rating above a certain level, etc., etc. So we have played with this data set pretty often. So here now we have got the cleaned data set out here without duplicate values, and where the numbers are out here, we've got no null values also, so that the mean of the data remains consistent. And that's it. So I hope you guys have understood this session on cleaning data. Basically, you have to do all of these. These are the tools that you have at your hand to clean your data. Bear in mind that here I have used mean. Instead of that, you can use any other logic, standard deviation, or anything that you want that makes sense to you for specific to your data set. So this varies from data set to data set, and that's it. We'll see you in the next video.